So in the previous lesson, we started solving or proving trigonometric identities. So just do one identity there, then we go to how to find or how to solve trigonometric equations. Okay. So here we have sine squared x. So we need to prove that sine squared x, open brackets, sec x plus cosec x divided by cos x tan x is equal to 1 plus tan x, like this. Okay, so here we need to show that the left hand side is equal to the right hand side here. So now we're going to identify the identities that we have on the left hand side there. So you notice that sec x is an identity here, cosec x is an identity, and tan x is an identity as well. So I can just substitute with those. So here we know that since sec x is equal to 1 over cos x, and also we know that tan x is equal to sin x over cos x, then cosec x is equal to 1 over sin x, like this. So we're going to substitute these identities here into the expression that we have on the left hand side, this side here. So here the left hand side, so here we have sin squared x, open brackets, 1 over cos x plus 1 over sin x, like this. Then everything that we have here divided by cos x multiplied by, so where there's tan x here, we substitute with our sin x divided by cos x, like this. Okay, so now we make this top bracket that we have here a single fraction. Then below here you notice cos x and cos x are going to cancel there. So here we're going to have sin squared x, open brackets. So the common denominator of the fraction that we have on top there is just sin x cos x. So we have sin x cos x, like this here. Then cos x into sin x cos x will remain with sin x multiplied by 1. We just have sin x like this here. Then plus sin x into cos x sin x will remain with cos x multiplied by 1. There we get cos x, like this here. Then below here, this is being divided by, since cos x and cos x they have cancelled, we're just left with sin x here, like this here. Now remember one thing here, this sin squared x here simply means that we have two sin functions that are being multiplied by each other there, so meaning that one of them there would cancel with the one that we have below here. So this just leaves us with sin x open brackets. So below here we're just going to have 1, so we can just forget about it there. So we have sin x open brackets sin x plus cos x, like this, divided by sin x cos x here. Okay, so sin x and sin x can cancel. Then we're left with sin x plus cos x divided by cos x, like this. Okay, so now remember, if you have a plus b over c here, this is the same as a over c plus b over c, like this here. So it's the same thing that we're going to do here. This is the same as sin x divided by cos x plus cos x divided by cos x, like this. Then we know that Sin x divided by cos x, we get tan x, plus cos x divided by cos x here, we get 1 there. So when you look at this, this is equal to the right hand side that we have there. So hence we've proved this trigonometric identity that we have there. Okay, so this was just a recap on what we did last time. So let's go ahead and look at trigonometric equations. Okay, so here we have trig equations. Like this here. So before we go ahead and try to see how we can solve trigonometric equations, let's discuss one thing that we call the quadrants. Okay, so quadrants here, a complete oscillation gives us 360 degrees like this here. So now when I talk about quadrants here, we divide this by 4 here. We're going to have 4 parts. So we have this part here, this part there, this part there, and this part here. So if we start from 0 degrees here, from 0 here, we go to 90 degrees there. Then we go to 180, then we have 270, then we go back to 0 here, which gives us a complete oscillation at 360 degrees there. So these segments that we have here are what we call quadrants there. So here we're saying we have 4 quadrants there, like this. So we know that this here is 90 degrees there, this here is 180, then here we have 270. Then when we go back to where we start from this side here, we say that's 360 and 0 degrees like this here, like that. Okay, so when you go from 0 here all the way like this, then you come back to 360 here, you've made a complete oscillation, which gives us a complete 10 there. Okay, so now remember, when we're talking about trigonometric functions, we're simply talking about the sine function, the tangent function, and the cosine function here. So now, the sines of these angles here, or the sines of these functions that we have here, they differ in whatever quadrants they are placed here. So now, in the first quadrant here, all the functions are positive here, like this here. So all functions here between 0 and 90 degrees, they are positive there. Then, between 90 degrees and 80 degrees, the only positive function that we have there is a sine function here. So here we're going to say that the sine function is a positive there. Okay? Then the remaining functions, the tangent function and the cosine function, are all negative in the second quadrant here. So we said this is the first quadrant, this is the second quadrant here, and this is the third quadrant, then this is the fourth quadrant that we have there. So we're saying in the second quadrant, the only function that is positive here is the sine function. The rest are negative. So here we have the tangent function is negative here, and the cosine function is negative in the second quadrant here. Then when we go to the third quadrant here, the sine function is negative and the cosine function is negative. The only function that is positive here is the tangent function. So the tangent function here is positive, the sine function is negative here, and the cosine function is also negative there. So in the third quadrant, the only function that is positive here is the tangent function, the sine function is negative, and the cosine function is negative there. Then now we go to the fourth quadrant here, which is between 270 degrees and 360 this side here. So here, the only function that is positive here is the cosine function. So the cosine function is positive there. Then the sine function is negative and the tangent function is negative as well here. So now, if we were to simplify this here, we can just say here, like this. We not say that this is the first quadrant, this is the second quadrant here. We have our third quadrant there, then we have the fourth quadrant this side here. So here we can simply say all functions are positive here, meaning that everything here, all the functions here are positive between 0 and 90 degrees. Then in the second quadrant here, it's just the sine function that is positive, meaning that tangent and the cosine functions are negative there. Then the third quadrant here, we have the tangent function, which is the only function that is positive here, meaning that the sine and the cosine function here, they're both negative there. Then in the third quadrant, in the fourth quadrant, we just have the cosine function, which is positive there. So this means that the sine function and the tangent function in the fourth quadrant, they are all negative there. Okay. So now, having discussed this here, let's go ahead and try to look at trigonometric equations here. Now, for trigonometric equations there, so we've discussed quadrants there, and we know which functions are positive in what quadrant and which functions are positive in what quadrant there. So, trig equations here. Like this here. So we're going to discuss 4 cases here. So the 4 cases that we're going to discuss first here is so we're going to name them. So let's say case 1 here. Okay, so before we do this, let me just make mention of something there. Okay, so now every trigonometric equation that you can come up with can be derived from this here. So we have let's say we have a sine squared x plus b sine x plus c equal to 0 here. So we're going to make all the 4 cases here from this equation that we have here. So now, let's say we have the first case here. So case number 1. Okay. So for case number 1, if a is equal to 0 here. So if this a that we have is equal to 0 here, we're going to have b sine x plus c equal to 0 like this here. So meaning that in this expression that we have on top here, where there's a here, if we substitute with a 0, this whole thing that we have here is going to be a 0 here, meaning that here we're just left with b plus sine x plus c here. Now, you meet equations that are in this form here, trigonometric equations that are in this form here. So what you just do with such equations there is you just go ahead and solve for x here. So we need to solve for x because it is an unknown equation that we have here. So to do this here, we can just take this c across the equal sign there. So we're going to have b sine x is equal to negative c like this here. Then we divide by b this side, we also divide by b this side. Then here we have that sine x is equal to negative c over b like this here. Now, when you're solving a trig equation and then you get to this stage here, so you will get to do this when we deal with an example here. So now, when you're solving a trig equation and then you get to this step here, you look at the number that you have here. So this side you have a trigonometric function which is sine x being equated to a constant this side here. So now, you look at the sign that this number has here. If you look at this number here, it is being attached to a negative sign there. This is a negative number. So what this means here, what this tells us is, you have the quadrants like this and the signs of functions there like this. So what this simply tells you is that the answers to this solution here are going to come from the quadrants where this sign function that we have is negative here. So mean that the solutions there are supposed to come from the third quadrant here and the fourth quadrant this side here. So mean that here you can simply just say x here is simply going to be equal to sine inverse of negative c over b like this here. So whatever solutions you're going to get here, they're supposed to come from the third quadrant and the fourth quadrant, because here we have a negative constant that we have here, like this. So then we can just conclude to say this type of a trig equation has two solutions there. So if the highest power of a trig function that you have there is 1, if the highest degree of a trig function that you have there is 1, just don't say that you're going to have two solutions, because here this function there is either positive in two quadrants or negative in two quadrants like that there. There are special cases when you just get a single answer. For example, if your answer is just 90 here, or if it's just 270 like this there. Okay. Alright, let's talk about the second case there. So let me just try to erase what we have there, then we talk about case 2. Okay, so for case 2, so suppose now b is equal to 0 here. So if b is equal to 0 here, if this is equal to 0 here, we're just left with a sine squared of x here plus c equal to 0 like this here. So then here we can just go ahead and try to solve for x there. So here we're going to have a sine squared x is equal to, we take the c the other side, we're going to have negative c like this here. Okay, so we'll talk about this symbol later on there. Then this side here, we divide by a, we divide by a like this here. Then you're left with sine squared x equal to negative c like this here. So this is different from the previous one that we had there. So the previous one there is, we just had the degree of the function that we have there was just 1. So now here the power that we have is 2 here. So meaning that we can't say we're going to get two solutions here because of what we have this side here. So what we simply do here is we introduce the square root this side and also introduce the square root the other side there. So I'll introduce something there. Okay, so now when you introduce a square root on one side where there isn't a square to cancel out with a square root, we usually put the positive and negative symbols that we have there. So meaning that here we're left with sine x here is equal to plus or minus the square root of negative c over a like this here. Now here we're more focused on this negative and positive that we have outside here. Let me talk about this for a while. Then remember, we go back to the quadrants again like this here. So we have all functions are positive here. The sine function is positive there, the tangent function there, and the cosine function like this here. Then what this simply means here is that these plus and minus symbols that we have here simply tells us that this trigonometric equation is going to have two solutions where this function is positive here. So two solutions where this function is positive are going to come from the first and second quadrant that we have there. Then there's also a negative such symbol that we have there. So this means that we are also going to have solutions from this function, or from the quadrants where this function is negative, which are the third and the fourth quadrants there. So now, if you count the number of solutions that we have here, you notice to say that you have 1 there, 2 here, 3 here, and 4 like that there. So if this is the case here, we can just conclude to say that this type of a trig equation gives us 4 solutions like this. So therefore here, if we were to solve for x then, we're going to have x here is equal to sine inverse of open brackets plus or minus the root of negative c over So like we said there, you have 4 solutions from the first quadrant, second quadrant, third quadrant, and fourth quadrant, like this here. So when you meet an equation that has a square here, just not say that you're going to have 4 solutions there. So you can just put a statement here. So this type of a trig equation has 4 solutions, like this here. So this type of a trig equation has 4 solutions like that. Okay, let's go to the third case there. So let me just erase what we have here, and then we look at the third case. Okay, so case number 3 here. So we'll just say case 3. So case number 3 here, there are instances where A, B, and C here are all not equal to 0 here. So what this simply means here, you're just going to have an equation the way it is here. So here we have S sine squared x plus B sine x plus C equal to 0, like this here. So now, there are instances where you have this here. So when you look at this type of an equation here, so this type of an equation, when you look at it, it's similar to ax squared plus bx plus c here. This is a quadratic equation that we have here. So meaning that the methods that we use to solve a quadratic equation there are the methods that are applicable here. So here we can just say this type of an equation. Okay, so let me just say to solve this type of an equation, so to solve this type of an equation, we can use either the factorization method or we use the quadratic formula. So in this case here, we have sine x there, so I can just simply say sine x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, like this here. So here, depending on what you get there, you're going to see the number of solutions that you can have here. Okay. So this is for case 3. So let's look at case number 4 there. I'm going to erase what we have here. Okay. So case 4. case number 4 here, there are instances when you are given a trigonometric equation that has a trigger identity. So you need to use trigger identities to simplify and then solve a trigonometric identity there. So I'm saying here, so there are times when a trig equation has trigonometric identities in it here. So before solving them, such equations, we first make trigonometric substitutions for the trig identities that we have there. Like this here. Okay, so we're simply saying for case number 4, there are instances when you're given a trigonometric equation that has trig identities in it. So what you just simply need to do there is you identify the trigonometric equations that, or the trigonometric identities that are there. Then you look for the suitable identities and you substitute in those equations that you have, and then we can get to start solving them like that. Okay, so now let's look at examples now here. So okay, let me just go to the next page here. Okay, so examples now. So the examples that are here are going to be following the cases they were presented them. So we had case number 1, case number 2, case number 3, 4, 5, and so on. Or they ended on 4. So I'll do 2 examples on case number 1, 2 examples on case number 2, and 2 examples on case number 3 there. Then 2 examples on case number 4, and then we can end our lesson there on trigonometric equations. Then from there we'll just start solving equations like that then. Okay, so example 1 here. So bear in mind, so example 1 is based on the first case that we talked about there. So here, solve the following trig equations. Okay, solve the following trigonometric equations there. So A here, we have 5 sine theta plus 3 equal to 0 there. So what we get to do here is we say 5 sine theta plus 3 is equal to 0 here. Then we can take this 3 the other side of the equal sign. We have 5 sine theta is equal to negative 3. We divide by 5 both sides. Even this side by 5 here. Then we have that sine theta is equal to negative 0.6. like this here. Now, if this is the case here, you remember when we were talking about cases there, when you look at this number, this is a negative number here, and the quadrants, we said all are positive here, the sine function, tangent function, and the cosine function there. So this simply tells us that we're going to get the solutions of this theta here are going to come from the quadrants where the sine function that is involved here is negative. So we have that the sine function is negative in the third quadrant and the fourth quadrant, like this here. So now, before we continue solving this here, let me just make mention of one thing here. So how you calculate the angles that you need there in respective quadrants. So there, for the first quadrant there, it's just the same angle that you get there. So now, in the second quadrant there, like this. So in the second quadrant there, you say your answer theta there is simply equal to 180 degrees minus, let's say alpha is the calculated angle minus the calculated angle alpha, like this here. Then in the third quadrant there, theta there is simply equal to 180 degrees there plus the calculated angle that you have, which is alpha in this case here. Then for the fourth quadrant, the angle that you're looking for there, or the answer there, is simply equal to 360 degrees minus alpha, like this here. Now, when you look at this here that we have here, we have sine theta is equal to negative 0.60 here. So what this simply tells us that sine here, the angle theta here is going to have solutions that are going to come from the quadrants where the sine function is negative. So meaning that we're going to use these two expressions here for the two answers that we need here. So theta here is simply equal to sine inverse of 0.6 here. So now sine inverse of 0.6, we're getting 38 or 36 point. So theta there is simply equal to 36.87 degrees here. Now, this is not the angle that we're looking for, because 36.87 degrees here falls in the first quadrant here. Now remember, this here gives us a negative number from that point there, meaning that our solutions are supposed to come from the third quadrant and the fourth quadrant here. So what do we do there? So the answers for theta here in this case, okay, so the answers for theta in this case here, we're going to say that the first one here, theta is equal to 180 degrees here plus 36.87, like this here. So this will give us 216.87 degrees here. Then the second solution that we're looking for here, so which is from the fourth quadrant there, because we know to say that the sine function is negative in the third and the fourth quadrant here. So I'm going to say 360 degrees minus 36.87. So here we have 323.13 degrees here. So these here are the two solutions that we're looking for here. So therefore, theta here is equal to 216.87, and also theta here is simply equal to 323.13 degrees, like this here. So these are the two solutions that we are looking for this in this equation here. Okay, let's look at the second example here. So I'll just erase what we have here. which is the second example there. So B here we have 1.5 tan x minus 1.8 equal to 0 here. So here we're looking at a tangent function here. So we simply just go ahead and do what we did with the previous example here. So we have 1.5 tan x equal to, when you take this 1.8 the other side here, we're going to have positive 1.8 like this here. Then we divide by 1.5, we divide by 1.5 here. Then here we're going to have that tan x is equal to 1.5, 1.8 divided by 1.5 like this here. Now when you look at this number here, okay, let's divide it first, then we talk about what I want to say there. So when we say 1.8 divided by 1.5, we're getting 1.2 here. So tan x is equal to 1.2 like this here. Now when you look at this 1.2 that we have here, this is a positive number that we have there. Then remember, always refer to the quadrants that you have here. So we know that all functions are positive in the first, the sine function, tangent function, and the cosine function here. If this is positive here, we know that the solutions of this equation that we have here are going to come from the quadrants where this tangent function is positive here. Meaning that we're going to have a solution from the first quadrant and the third quadrant, because those are the only quadrants where the tangent function is positive there. So then, okay, so then let's go ahead and solve. We complete this here. So solving this here, we're going to have that our x here is simply equal to tan x, or tan inverse of 1.2 here. So tan inverse of 1.2, we're getting 50.2 degrees there. So we have 50.2 degrees. So we have x here is equal to 50.2 degrees like this here. Now this 50.2 that we have here falls in between 0 degrees and 90 degrees here, like this here. And we know that if it falls here, the tangent function is positive there, so meaning that this is part of the solution as well there. Then we get another solution, which is in the third quadrant. So in the third quadrant there, we said it's 180 degrees plus the calculated angle that we have there. So our calculated angle here is 50.2 degrees, so meaning that x here is equal to 180 degrees plus 50.2. So our x there is going to be 230.2 degrees like this here. So if you look at this, we have two solutions as well here. So this is how we go about equations that look like this here. Okay, let's look at examples now on case 2 there. So I'll just go to the next page here. So we have example 2 here. Solve the following. Trig equations. So for A here, we have 2 minus 4 cos squared theta equal to 0 like this here. So when you look at this here, we have the function that we have is being raised to the power 2 here. So I mean that we're talking about the case 2 that we talked about earlier on there. So what we simply do here is we take this to the other side. This side, then we're going to have negative 4 cos square theta is equal to negative 2 here. Then we divide by negative for both sides, even negative 4 here. Then we're going to have cos square theta is equal to half. So which is the same as cos square theta here is equal to 0.5 like this here. Now, this function here is being raised to the power 2 here. So what do we do here? We introduce the square root on both sides and we solve for this equation here. So when you introduce the square root here, we're going to have the root of cos square theta equal to plus or minus the root of 0.5 like this here. Remember, each time you introduce a square root where there is no power 2 that's supposed to cancel with the square root, you introduce the plus or minus here. Then here, this will cancel. Then we have that cos theta is equal to, so the square root of 0.5, okay, so we have cos theta is equal to plus or minus 0.7071 like this here. Now here, because here we have plus and we have a minus sign here, this simply tells us that we're going to have 4 solutions here, because when you look at the quadrants the way they are here, you have A, S, T, C like this here. This function here is positive in 2 quadrants here, meaning that it's positive in the first quadrant and the 4th quadrant there. Then there's a negative sign here telling us again that this function here is negative in the 2nd quadrant and the 3rd quadrant. So mean that if you add all the answers together that we have here, you're going to have a maximum of 4 solutions there. So here we can just go ahead and try to find theta first. So theta here is equal to cos inverse of 0.7071 like this here. So then cos inverse here of this function that we have, we're getting 45 degrees there. Now we have 45 degrees like this here. So this 45 degrees here is part of the solutions because it falls in between the 0 degrees and the 90 degrees there here, which is the first quadrant there, and we have a solution because of the positive sign that we have here. We have solutions that are supposed to come from the quadrants where this is positive here. So we also need to get the solution in the 2nd quadrant. Remember, for the 2nd quadrant we said theta here is equal to 180 degrees minus the calculated angle, which is 45. So this will give us 135 degrees here, like this here. Then we go to the 3rd quadrant, we said it's 180 degrees plus the calculated angle, so in this case it's 45. So if you add this here, we're going to get 225 degrees here. So 225 degrees like this here. Then in the 4th quadrant here, where it's positive there, we said it's 360 degrees minus the calculated angle, in our case it's 45, so this will give us 315 degrees here. So therefore theta has 4 solutions here. We have 45 degrees, we have 135 degrees, we also have 225 degrees there. Then we have the last one here being 315 like this here. So when you have a function that has the power 2 there, this is how you go about solving or finding the solutions there. Okay, let's look at the second example on this. I'll just erase what we have here. Okay, so the second example here, we'll name it B. So here we have solve 1 over 2 cot squared theta is equal to 1.3 here. Okay, so I'll talk about the cot later on. Now here, this here, okay, so to find to get rid of this fraction that we have, this is has been put in order already, so you can just multiply the whole equation that we have by 2 there. So we're saying if you have a 2 here, you multiply it by 1 over 2 cot squared theta. You do the same thing even this side, 2 multiplied by 1.3 cot theta like this, or 1.3 just there. So now, this here, the 2 that we have there, they're going to cancel out, so we're going to have cot squared theta is equal to 2.6 like this here. Now, remember, here, we have the square root that we have, or we have the power 2 that we have here, so mean that we need to introduce the square root here. So we're going to have the square root of cot squared theta is equal to plus or minus the square root of 2.6 here. So here we're going to have cot theta is equal to, so we find the square root of 2.6, which is 1.61 there. So we have 1.61 like this. Okay, so okay, to do this first. Now, if this is the case here, remember that. So here we have our cot theta. So before I talk about something else, so 1.61 here. Remember that cot is an identity here. So cot here, cot theta is the same as cos theta over sin theta here. At the same time, this is the same as 1 over tan theta, like this here. So meaning that where there's a cot theta here, we can replace with 1 over tan theta there, and then we solve here. So meaning that here we have 1 over tan theta is equal to 1.61. So this is the same as over 1. We multiply here, we're going to have 1.61 tan theta is equal to 1. We divide by 1.61. Even this side by 1.61 like this. Then here we have that our tan theta here is equal to 1. Also, we still have a plus or minus here. So even here plus or minus, we continue having it there. So here again plus or minus there. So we have 1 divided by 1.61. So we have so we have plus or minus 0.620 like this here. Now, this simply tells us that we're going to have solutions in all the 4 quadrants because we have plus or minus in front of the number that we have here. So theta there is equal to tan inverse of 0.620. So then we have that our theta here. So the first solution that we're going to have theta there, so tan inverse, we have 31.8 degrees there. So we have 31.8 degrees here. So in the second quadrant here, we said it's 180 degrees minus the calculated angle that we have there, so it's supposed to be 31. Okay, so minus 31.8 degrees, so this will give us 180 degrees minus 31.8. So we get 148.2. So we have 1.8.2 degrees. So in the third quadrant there, where the tangent function is positive, we say it's 180 degrees plus 31.8 degrees here. So here we're going to get 211 0.8 degrees. Then the final, in the last quadrant there, we have 360 degrees minus 31.8. So we have 228.2 degrees here. So we have 2 or 328.2 degrees like this here. Okay, so therefore now, the four solutions that we have here, we have theta here is equals to 31.8 degrees, 148.2 degrees, we have 211.8 degrees, and also we have 328.2 degrees like this. Okay, so these are the solutions to the question that we had here. Okay, so when you're solving a trigger identity here, and you notice to say that you have or when you're solving a trig equation and you notice that you have a trigonometric identity in it, you can just recall the trigonometric identity, then you make a substitution and you solve for the required solutions this side here. Okay. Alright, let's look at example 3. So for example 3, the same thing. Solve the following equations. So A, we have 8 sine squared theta plus 2 sine theta here minus 1 equal to 0 here. So now, when you look at this trigonometric equation that you have here, this looks like a quadratic function that you have there. So now here, we can just apply either the factorization method or we use the formula there. So now, in this case here, if we want to use the factorization method, we have our product here is negative 8 and our sum is 2 here. So two numbers we can get, we multiply, we get negative 8, we add, we get 2 here. So we have 2 and 4 give us so if we add 2 and 4, if we multiply 2 and 4, we're going to get negative 8. If to add this, we're supposed to get a 2, so meaning that negative 2 is going to be a negative number there. So we can rewrite this as 8 sine squared theta plus 4 sine theta minus 2 sine theta minus 1 equal to 0 then. We can factorize here. We look for what's common. So 4 sine theta is common there, so we have 4 sine theta. Then open brackets here. We have we're going to remain with 2 sine theta. So 2 sine theta there plus 1 like this here. Then on these two terms that we have, this side negative 1 is common, so we're going to say minus 1 open brackets. We have 2 sine theta plus 1 equal to 0 here. Then we put this together there, we're going to have 4 sine theta minus 1 and 2 sine theta plus 1 like this is equal to 0 here. Now here, we have two equations here. Remember when you're solving quadratic equations and you reach this step here, you equate this to 0 and you also equate this to 0 and then you solve the respective equations that you have there. So here we're going to have 4 sine theta minus 1 is equal to 0 and we also have 2 sine theta plus 1 is equal to 0 here. So then here we can take the negative one the other side here. So we're going to have 4. So we'll start with one equation here first. So we have 4 sine theta is equal to 1. We divide by 4. We divide by 4 here. So then we have that sine theta here is equal to 1 over 4. So now, this 1 over 4 that we have there is a positive number. So meaning that we're going to get solutions from the quadrants where the sine function is positive here. So there 1 over 4. So we have sine theta is equal to 0.25 here. Then theta here is equal to, so now if this is a positive number that we have here, we know that we're going to get our solutions from the first quadrant and the second quadrant where the sine function is positive here. So theta here is simply equal to sine inverse of 0.25. So sine inverse of 0.25, we have 14 degrees there. So theta here is equal to 14 degrees here. So 14 point, so let's just say 14.3 degrees here. We round it off. Then in the second quadrant where we need our answer from there as well, so we're going to have theta here is equal to 180 degrees minus 14.3 degrees here. So this will give us 168 or 165.5 degrees here. So we have 165.5 degrees here. So these are the first two solutions of this equation that you have this set here. Then let's go ahead and solve this equation here. So I'll just do this there. We solve this equation here. We have 2 sine theta plus 1 equal to, or plus 1 here, so equal to 0. So we have now here 2 sine theta is equal to negative 1. We divide by 2. We divide by 2 this side. Then we have sine theta is equal to negative 0.5 like this here. So now, in this case here, this side we have a sine function being equated to a negative number. So this simply means that the function that we have here is supposed, or the solutions for this function that we have this side are supposed to come from the third and fourth quadrant there, since that's where the sine function is negative there. Okay, sorry about that. So here we're going to say that theta here is equal to sine inverse of 0.5. So sine inverse of 0.5 we're getting 30 degrees here. So theta here is equal to 30 degrees. Now, when you look at this 30 degrees here, this 30 degrees falls in the first quadrant there. In the first quadrant is positive for the sine function. So we need solutions from the quadrants where this function is negative. So we're talking about the third quadrant and the fourth quadrant. So therefore now, the solutions we're looking for theta here is simply going to be equal to 180 degrees plus 30 degrees. So if you add these, you're going to get 210 degrees here. Then the other solution comes from the fourth quadrant here. So 360 degrees minus 30, which will give us 330 degrees like this here. So now, therefore here, the solutions for this here, theta here is simply equal to, the first solution we have is 14.3 degrees. The other solution is 165.5 degrees. Then we have 210 degrees and also 330 degrees like this here. So these are the solutions of this equation that we have on top there. Okay, let's look at example 4. So example number 4 here. Solve the equation. So here we have we just solve one example here. So 5 cos squared theta plus 3 sine theta minus 3 equal to 0, like this. Okay, so now when you look at this equation here, we have two different functions or two different trigonometric equations that are involved in this function that we have here. So meaning that we need to find an identity that we're going to substitute here. When you look at sine theta is not a trigonometric identity here, but then we can get an identity for cos squared theta here. Remember from the previous lesson, we had the Pythagorean identity where we said 1, or rather sine squared theta plus cos squared theta is equal to 1, like this. So we can manipulate this into having cos as the subject there, then we substitute into that thing. So here we take sine squared theta. The other side we're going to have cos squared theta is equal to 1 minus sine squared theta, like this. Okay, so here now we can go ahead and substitute into the equation that we have this idea. So meaning that where there is cos squared theta, we just substitute with 1 minus sine squared theta here. So here we're going to have 5 open brackets 1 minus sine squared theta plus 3 sine theta minus 3 is equal to 0 here. Then we're going to have 5 minus 5 sine squared theta plus 3 sine theta minus 3 equal to 0 here. So we can add these two like terms there that we have. We have negative 5 sine squared theta plus 3 sine theta plus 2 equal to 0 there. So now the leading coefficient here is a negative value, so we can just try to divide by negative 1, even here negative 1 and negative 1 here, so that it becomes positive there. So we have 5 sine squared theta minus 3 sine theta, like this, minus 2 equal to 0 there. Now in this case here, we can either use the product and sum method to find the values for this here. So now if we use the product and sum method, so you notice that our product in that case is going to be negative 10 and our sum is negative 3. So meaning that two numbers we can multiply to get 10, we have 5 and 2, like this. Then the sum is negative 3, so meaning that 5 is going to be negative there. So meaning that this can be written as 5 sine squared theta minus 5 sine theta plus 2 sine theta minus 2 equal to 0 here. Okay, so I'll erase what we have on top here so that we have enough space to solve our problem there. Okay. Alright, so then here, let me just do this. Okay, so here now we have the this common there is 5 sine theta, so we're going to have 5 sine theta, open brackets, we have sine theta minus 1 plus, then we check this side, so 2 is common there, so we're going to have 2 open brackets sine theta there minus 1 equal to 0 like this here. So then here we put the terms together, we're going to have 5 sine theta plus 2 and also sine theta minus 1 equal to 0 here. Okay, sorry. So now here we equate this and this to 0 here, we're going to have 5 sine theta plus 2 equal to 0. We also have sine theta minus 1 equal to 0 here. So I can just simply solve this first. So I have sine theta is equal to 1, or it's positive 1 there. So then theta here simply equal to sine inverse of 1 like this here. So sine inverse of 1, we're just going to get 90 degrees here. So theta here simply going to be equal to 90 degrees, just like that here. Okay, so now let's solve the other part there. So here we take the 2 the other side of the equal sign, we're going to have 5 sine theta here is equal to negative 2. We divide by 5, we divide by 5 here. Then we have that our sine theta here is equal to negative 0.4. So we have negative 0.4 here. Then now, since this sine theta is being equated to a negative number here, it simply tells us that solutions are going to come from the quadrants where this function is negative there. So meaning that here we're going to have sine theta here simply equal to sine inverse of 0.4 here. So we have theta here being equal to sine inverse of 0.4. We have 23.5 degrees there. So sine inverse of 0.4, we have 23.5 degrees there. Okay, so 23.8 or 0.6, let's make it 6 degrees here. So now, since this is negative here, these are not the solutions that we're looking for. The sine function is negative rather, in the third quadrant and the fourth quadrant there. So what we're simply going to say here is we're going to say theta here is equal to 180 degrees plus the angle that we've calculated in the third quadrant there. We get 203.6 degrees. So we have 203.6 degrees. Then we also say theta here is equal to 360 degrees. Okay, so theta here is equal to 360 degrees minus 23.6 degrees here. So 360 minus 23.6 degrees. So we have 336.4 degrees like this. So therefore now, the solutions for theta here are simply here, 90 degrees, 203.6 degrees, and 336.4 degrees like this here. Okay, so let me give you practice questions. So practice questions here. So I want you to solve this. We have 3 cosec square theta minus 4 cot theta minus 5 equal to 0. Then B here. Five plus 3 cosec square theta equal to 8. Then C. Four minus 7 sin theta equal to 0 here. Okay, so here you notice that I've covered all the cases that we've looked at today. Alright, thank you.